Good evening, everybody. Welcome to day 2 on week 1 of the semester. Today, we are going to start discussion on chapter 1 material, which is titled Chemistry Basics. Specifically, we're going to be discussing matter and measurements. So the first thing that I want to mention to you guys is what is the formal definition for what chemistry is? And as you can see here, chemistry is defined as the study of composition, structure, properties, and reactions of matter, okay? Matter in general is just another term that is utilized to describe all of the substances that are actually making up the world. Now, when it comes to chemistry, and you may be familiar with this because you've seen it in TV or you watch the show, but sometimes in chemistry, the part that gets more highlighted is always of chemists make drugs, or chemistry has to do with drugs, and especially illegal drugs. So for example, you can see here in the first image that I placed that Breaking Bad became a very popular show, and maybe some of you have heard of Breaking Bad. Put a 1 in the chat if you have heard of Breaking Bad before. Okay, a few students. See? And hey, the chemistry there was accurate, you guys. Anyways, when it comes to shows like that, this is where I'm like, okay, cool. Chemists are being highlighted, but maybe in a way that I would like not to be shown. I wish that there's other shows that will highlight us in a different light. Now, chemistry is all around us, as I mentioned to you guys the first day of class. Now, put a 2 in the chat if you have ever gone to see fireworks, which is what we see in the second image, right? Great. I see that a lot of you guys, maybe during the summer, went and even caught some fireworks for 4th of July, or you enjoyed going to Disney and you see fireworks. Understand that all that beautiful colors that we see in the fireworks has everything to do with chemistry. All the colors that you see in the fireworks are actually coming from the fact that we have elements that specifically when you ignite them, they are going to show a particular color in the visible light. And that's what you actually see in fireworks. Now, more importantly, in order for us to survive and to live our lives, we need to eat food. Put a 3 in the chat if you enjoy food, all kinds of food. See, everybody, yes. And I'm sorry, I'm not trying to make you hungry, but what I want you guys to start realizing is that even in food, we see specifically that when the body takes it, the body is not going to say, ooh, these are beautiful hot Cheetos. The body's not going to say like, ooh, this is so nutritious. Oh, let me take an apple. Or when it looks at it, it's just going to be like, oh, wait, you should think about that. Well, it may not look at it in terms of brands, but it's going to look at all of those different foods in terms of biomolecules, because that's what it's detecting. So I hope that by the time that we get to biochemistry, you guys are able to see how food is actual chemicals that when the body receives them, it can be converted into fuel. And in chapter 12, we are actually going to do a summary of how the body take those molecules and it converts it into fuel in order for us to have a functioning body. Now, one of the things is that when it comes to chemistry, sometimes molecules can be intimidating. And I placed in the slide just several molecules just to give you a taste of how molecules look like. And I'm going to label them A, B, C. Let's say that this is A, this is B, and this is C. These molecules may mean something to you guys, may not mean anything to you guys yet. For me, as a chemist, some of these I have memorized, but just at first glance, okay? I want people to put in the chat, which of these molecules do you think that it is the most dangerous? Make a vote. Put it in the chat, A, B, or C, just by looking at it with whatever. Just vote. Ooh, a lot of B's. There's some A's, okay. There's some C, okay. I see. Great. So this is the thing, and this is the reality, you guys. In this course, we are going to understand molecules to the level that we will be able to see some and identify them. We will see some of these molecules and know the different type of elements that are in them. And once we get into organic chemistry, we're going to understand what functional groups, meaning what are the signature attachment of atoms that these molecules have. So let me introduce these three molecules to you guys. Letter A, that is the molecule that represents meth. That's meth. And I know some of you put A, maybe you knew that that was meth. Maybe you were just like, let me just pick that one. But again, this is just illustrated. If you had no chemical knowledge and you just look at these molecules, you'd be like, oh my God, they're so intimidating. Just treat them like puppies. We are here going to understand how they are going to interact in the body, how they look chemically. So we are going to learn a whole bunch of things of different molecules, okay? Letter B, okay, is a molecule that it is, you do it by choice, but some people out there in the world every morning religiously make a long line at Starbucks to enjoy that molecule. What do you think that molecule is, you guys? What's letter B? Which a lot of people is super. Thank you. Yes, caffeine. Isn't it delicious? Oh, caffeine is so awesome. Maria, question. You raised your hand. Question? No? Then let's move on to letter C. In letter C is a molecule that maybe when you're sick and you have a cold, if you grew up with me, my mom and my grandma would be like, you need to drink orange juice because the orange juice has this molecule that is going to help you get rid of the cold. So what is letter C?
Ascorbic acid.
Ascorbic acid. So what is, how do we know ascorbic acid as?
Vitamin C.
Excellent, vitamin C. So what I'm trying to illustrate right now, just giving you guys a preview of molecules, because we will be, building our knowledge to understand molecules, is that you should not be afraid of molecules. You should understand molecules. You should understand the chemical features of molecules, because the more chemical knowledge you have about the world around you, you'll be able to understand it better, okay? Now, in chapter 1, the first thing that we're going to learn is to classify matter, okay? Now, as I mentioned a few moments ago, matter is going to be the substances that are in the world around us. Now, the formal definition of matter is anything that has mass and occupies space. As you can see in the left side of the slide, you have some examples of matter, okay? You have a piece of wood, a stone, water, a bucket, glass, a gas pump. So fire, for that matter. All of those are examples of matter. In that slide, I also have examples of things that are not matter. Now, let's just learn that when it comes to this, it's not that they do not matter, it's just that as the definition in chemistry, these things are not considered matter. So a rainbow is not matter. Light is not matter. Heat is not matter. Memory is not matter. A reflection, love, and understand that in chemistry, we will consider those things not defined as matter, again, because they don't fit the definition of they have mass and occupy space. Now, when it comes to dissecting what are the two large families of what matter is, we need to understand that matter can be defined as either pure substances or mixtures. And let's just dig in a little bit more on like, okay, how do I know that something is a pure substance or something is a mixture? So again, matter can be pure substance or it can be a mixture, okay? So there are two subgroups within pure substances. So as we can see here, when we have this large family of pure substances, we can have pure elements and we can have pure compounds. And those are going to be the two members of the pure substance family. An element is defined as a substance that has one type of atom, okay? Now, where do we find them? In the periodic table. Okay, that's where they at. Compounds are defined as substances that are composed of two or more elements, always combined in the same proportion. Now, understand that these elements that are coming together and forming a compound are actually chemically linked. So we're going to have some type of union, which in chemistry we call bond, that are going to connect these elements together to form a compound. On the other hand, matter, instead of being a pure substance, it can be a mixture. And a mixture, by definition, is going to be a substance that is made of two or more different chemical substances, okay, that are physically mixed, you guys, but they are not chemically bonded. Now, when it comes to the family of mixtures, okay, there are two types of mixtures that we can encounter in matter, and that is a homogeneous mixture or a heterogeneous mixture. What makes a mixture be homogeneous or heterogeneous is just basically when you look at it, if it's uniform or if it's not uniform. So a uniform mixture is what we call the homogeneous mixture. So the different parts that make that mixture, when you look at it, you cannot identify them. So that's what I mean with uniform. On the other hand, for a heterogeneous mixture, we are going to have the different components present, but you will be able to see them in the mixture. That's why you guys see the examples here for specifically pure elements, pure compounds, homogeneous mixtures, and heterogeneous mixtures. Now, one of the things that it is known is that when you have a mixture, as you guys can see here, those mixtures through separation methods can be converted into pure substances. Now, it depends on how the mixture is there, but understand that mixtures could, through separation methods, turn into pure substances. Now, I want to illustrate to you guys some examples of separation methods that you may be aware of or you may not be aware of that exist out there. So put a 1 in the chat if you have ever tasted, consumed, or know of sea salt. There you go. People know what sea salt is. Okay. Put a 2 in the chat if you know how sea salt is collected. Okay, great. There's some people that know. So in the first image that we see here is illustrating how if you have salt water, then through utilizing temperature, you're able to separate the salt from the water, meaning the white stuff that you see here is the salt. And once the temperature was incorporated into that substance, you separated the water from the salt by turning water from liquid form to water into gas form. And that salt that you leave behind is how you separated the salt from the water. And that's where sea salt comes from. Now, for those of you that brew your own coffee in the morning, like it doesn't matter what instrument you use, what apparatus you use, what you're doing is separation. Okay, so when you have a coffee filter that lets you separate, okay, that water that now is combining with some of the coffee that has been ground, and then once the water comes through, we all have in chemistry chemical terms for that eluate that comes out, that we are not going to deal with in class, but I want you guys to realize it. When you have ground coffee and you combine it with water, some of the molecules that are soluble in water that were in the ground coffee go into the water. Now, utilizing that paper coffee filter, you are separating the coffee ground from the water, and whatever compounds solubilized in the water are now filtrated, and then you don't get the grains, okay? So that is just illustrating the separation of a mixture in which now you are taking into account that some of the substances that were in the coffee that was ground is able to go with the water, and then maybe that's what you drink, okay? There's other separations that are going to be done based on the property of the function. So as you can see here in the last example, we have a magnet that can be used to separate iron from sand. What we're doing there is that we are taking into account that iron has magnetism. So specifically, the iron will be attracted to the magnet. It's going to leave the sand behind, and you're separating the components of that mixture. I'm just trying to illustrate to you guys via this conversation how actual separations, you may be more familiar with them than maybe you thought before. Now, the first problem that we're going to do from the in-class worksheet is going to be determining if the following substances are pure substances or mixtures, okay? Within chapter 1, we are going to learn about elements. So if you are not familiar with the periodic table, that is okay. That is the next topic that we're going to talk about. But right now, I'm going to give you guys 2 minutes to classify the following list into pure substances and mixtures. So I'll give you guys 2 minutes. Okay, let's get started. As we go through these, we're going to utilize PS for pure substances and M for mixtures, okay? And we're going to put the answer in the chat. Let's get started. Sodium. What's the classification for sodium? Excellent job, you guys. This is a pure substance. This is an element. Number 2, water. Ooh, I saw a couple of M's. No, water is a pure substance, okay? I don't want you guys to overthink these. Water is a compound. Okay, remember, water is just H2O. And we're not going to go into the whole thing of like tap water, distilled water, deionized water. No, when I say water, we're assuming H2O, okay? Soil, what is soil? Love to see those M's, great job, that's a mixture. Coffee, what about coffee? It is a mixture. I saw a pure substance somewhere. Oxygen. What about oxygen? Excellent job. Pure substance, that is an element. Isopropyl alcohol. I see some M's, I see some pure substances. Isopropyl alcohol is a pure substance. For those students that are like, Dr. Luz, how do I know? Right now, you guys we haven't talked about naming compounds, and we're actually not going to touch on alcohols until later in the semester. So this is going to be the main thing about these. If I know that you guys do not know the chemical formula for a particular name, then I will put the elements that are part of the chemical formula for that compound, okay? So for example, for isopropyl alcohol, most likely what you guys are going to see in your first exam is that you will have isopropyl alcohol, isopropyl alcohol, which is a compound, but then you guys are going to see that I will say coma, and then this is C3H8O. So if you see a general name, and then you see the chemical formula, and if you see, oh, there's symbols and there's numbers in the bottom of the symbols, then you know that that is going to be a compound, okay? Put a 1 in the chat if that makes sense. This is only going to happen for the compounds that I know that you guys don't know their chemical formula yet, because by the time first exam comes, we are barely going to start naming compounds. So if it's something that we have discussed in class, then I'm going to be assuming that you guys know the chemical formula. For other things like isopropyl alcohol, no. But for example, for number 7, for now, let me just do this. Carbon dioxide, which came up in the Kahoot quiz that we did on Tuesday, this is CO2. What would it be, you guys? Pure substance or mixture? Great job. It is a pure substance because we see, oh, there's a couple of elements, and then we see that there's numbers under the elements, okay? So this is a pure substance. This is a compound. So somebody brought up something interesting in the chat, and let me just discuss this. Rubbing alcohol, or whenever you have alcohol bottles that you guys buy at the pharmacy, you may notice that it has a %. 70%, 60%, even 90%, right? Whenever you're buying those that you have at home, those are going to be mixtures, because the reason that they give you a percent is because they're telling you only you have out of this bottle, 70% of it is going to be the alcohol, but then the rest of the percentage is water. So at that point, we're going to learn later in the semester how alcohol actually dissolves in water because of the atoms that are present in the molecules to a specific attractive forces that they're going to have. So understand that, again, for now, all of those concepts are going to continue to be developed here. But what you have at home, if it has a percent, then you know that that is a mixture because the rest of it is water. Number 8, cake batter. What is that? Great, that is a mixture. Air, we did that one. Awesome. That is also a mixture. Lastly, chicken noodle soup. Awesome, you guys got this. Now, let me just mention something, and you guys are here, and for those of you that are here, hopefully the people that did not attend are going to watch this video. This is one of the things that I'm just trying to see. It was like, did people get it in lecture or not? For some reason, the minute, you guys, that I add the word organic in front of a substance, all of a sudden, people are like, oh, organic, pure substance. So for example, what if I give you guys organic coffee? And I ask you, what is that? A pure substance or a mixture? What do you guys think? Thank you, Atasia. Thank you. That is still a mixture. I don't care it is organic. If something before placing the word organic in front of it was a mixture, after placing the word organic will still be a mixture. I don't know why or how I put organic, like it could be fruits, right? Like organic cherries, and all of a sudden students go, oh, pure substance because it's organic. No, my family, that is still a mixture. If it's a mixture, before I put the word organic, writing the word organic does not make it pure, okay? Remember, pure substances in chemistry is limited to being an element or a compound, because a compound is just elements that are combined with one another. Any questions? If you're given substances, determining if they are pure substances or mixtures.
I have a question.
Yeah, go ahead, Vanessa.
So isopropyl alcohol is a pure substance, and it's those elements, but like regular, like the one that we use at home, is a mixture, but isn't it just a variation of the different amounts of the same substances?
But remember
like,
that
doesn't one just have like a ratio of more water to like other things, and the other one just has a higher ratio of something else and less water?
No, actually,
no?
to be honest with you, we can get, like as chemists for laboratory purposes, we can get pure isopropyl alcohol. You can get jugs of it. It's just
Yeah, but
that
it's not different in just the sense of a ratio of elements.
no, that one doesn't. No, it.
Okay.
Let me specify that. So if I work in the stock room for the chemistry department, and I buy isopropyl alcohol, just buy a jug of isopropyl alcohol. What they're selling me is every single molecule in that liquid substance that I see is going to have 3 carbons, 8 hydrogens, and 1 oxygen. Again, we haven't talked about structure yet, because every single molecule in there is isopropyl alcohol. On the opposite, when we buy isopropyl alcohol, specifically that the bottle says 90%, 70%, 60%, then in that liquid, that will look very similar or even identical to pouring just pure isopropyl alcohol, because that one says 60%, then it has 60% isopropyl alcohol, 40% water. That's what makes it a mixture. Because if you look at the chemical composition of it, there's going to be water molecules found and isopropyl alcohol molecules found.
And so even though those molecules are all technically elements, because they are comprised of multiple elements, both the water and the isopropyl alcohol, that's what makes it a mixture?
Yes, because
Okay.
as a substance, water is water.
Mhm.
Isopropyl alcohol is isopropyl alcohol. So just to give you a little bit of an introduction, if you have, let's say that 90%, let me just change the color of this. If you have that 90% isopropyl alcohol, that's a great question. Then you will know that that 10% is water, right?
Mhm.
If we investigate this, you will have this in the jar. You will have both of these things found in there. Because isopropyl alcohol is its own substance. Water is its own substance. They have connectivity to atoms together. While if what I'm referring to in number 6 is just this in a jar. What you buy at the store, which is 90%, 60%, is a combo of these two. So at the molecular level, yes, you have elements, but look at the connectivity. They are individually compounds, but those are compounds that are coming together.
Okay, thank you.
So there is a comment in the chat, because the water and alcohol are chemically linked to each other, is a mixture. Yes, and we can even separate them, right? You can have chemical means of separating the alcohol from the water, because they will have different boiling points. If you target a specific temperature, you can actually introduce temperature and then evaporate the alcohol and leave. Great job, exactly. And then leave the water around. That's how like ethanol for like making vodka or anything else. Like one of the labs that you guys are making is actually fermentation, which is you're creating a mixture. There is alcohol that is made soluble. I don't know how much you guys are going to be separating and creating the ethanol, but overall, it is the separation of things in a mixture. Does that make more sense? Are we good? Any other questions? When it comes to what is a pure substance versus what is a mixture? Excellent. Put a 1 in the chat if we're ready for the next section. Great. So then in our textbook, there is a discussion about elements, compounds, and the periodic table. I know that so far we have talked about matter. We have mentioned that those elements live in periodic table, but at least let me introduce to you guys specifically, how does the periodic table actually looks like and what kind of information we can get from the periodic table. So this image that you guys see here in the slides, this is one of my favorite periodic tables that are out there. Because if you look closely at the periodic table, you can actually see images specifically of each one of the elements in their elemental form. So as you can see here, neon, argon, krypton, xenon, they are in halogen light, making halogen lamps. We can see, for example, boron which is a metalloid. We can see a pure form of carbon, like a diamond. So when we go through it, these are how elements actually look like, okay? Now, whenever we start seeing that there's going to be like shields or images of people, that's not how the element looks like. This is just the people that inspired the name for that element. Because what happens in the periodic table is that at some point these elements were created in the laboratory. So it is important to note that once we get to that point, then those elements are radioactive, they're made in the lab, they're named after people, so on and so forth. So as we just discussed, the elements in the periodic table specifically are pure substances, and all of the materials that are around us to date are going to come from combinations of those elements that we have here, okay? Now, let's understand that when it comes to elements, specifically, they cannot be broken down into simpler substances. So the element is going to be the smaller form of that substance. Now, when it comes to elements and their names, understand that elements and their names can be derived from planets, mythological figures, minerals, colors, geographic locations, and even famous people. This table I actually obtained from a different resource, but I just wanted to give you guys some example of some elements and what is the source of their name. So as you can see, uranium comes from the planet Uranus. We have titanium, which actually comes from the mythological character of Titans. And as we go through these, we can actually see that we have an element that is actually named after the state that we live in. So as you can see, California, which its symbol is CF, is actually named after the state of California, okay? There is one more element, okay, that is named after the state of California, okay? So sorry that the resolution of the image is not really well, but I just wanted to illustrate here. This is Californium right here, 98. The one right before, BK, berkelium. Berkelium is also named after the state of California because it was named after Berkeley. So you see Berkeley up there. There's a question in the chat. Why are there 112 to 115 question marks? Because this is an older periodic table. So when this one was released and put in the press, we didn't know which elements or what were going to be the names of the elements up to 118. But by now, the periodic table is up to 118 elements. And you guys are going to see the names from 112 to 118 in a further slide, which I have a current periodic table. So those are new. I think the Oganesson, which is the last one, 118, that one was discovered, I want to say 2016. Like it's recent. Yeah, so I'm telling you, you guys, that's one exciting thing about being a chemist. I think as we progress and then people keep on, you know, making elements, you know, discovering them in the lab and all that kind of stuff, you know, the periodic table, maybe by the time I retire, it's going to look super different. Because again, when it comes to these last ones, they are created in the laboratory. We don't have evidence of these guys in nature. There are all elements created at the laboratory. There's active research just discovering elements. Now, I know it's always the question to students, Dr. Luz, do I need to memorize all the periodic table? I've given you guys here the list that I think is essential and important. And when it comes to examination, this is the one that I want you guys to understand. So please, when it comes to memorizing the elements, this is the list that you should go after, okay? I want to specify that it is important that you guys are familiar with the elements, how to write the chemical formula correctly, how to spell the name correctly, because chemistry can be like a language. You need to know how to correctly write it down. So make sure that you understand how to write correctly the symbols, how to correctly spell the elements. But these are the ones that you guys need to know for this class. So let me just write it as a note. Memorize this list for exam 1, because it's very important. When I'm teaching, I always like to point out, hey, you guys, make sure that you know this, make sure that you have this for the exam. So when it comes to the elements and which one I want you guys to be familiar with, these are the ones that I want you guys to know. Now, let's continue talking about the periodic table. And as I mentioned a few moments ago, this is how the periodic table actually looks like now. The periodic table has 118 elements known to date. Understand that out of all of these elements, pretty much 1 through 92 are the ones that have been detected in nature, and the majority of the ones that is in the 100s. Specifically, as I mentioned to you guys, because this is what was mentioned before. Oh, what happened from 112 to 118? These are the actual names for them. But you see, they were created in the laboratory, and even the mass of the element is really not known because they're very short-lived and they're super radioactive. Now, when it comes to the organization of the periodic table, it all started with the gentleman that you see on the right side. The name of this person is Dmitry Mendeleev. And Dmitry Mendeleev was the person that started the classification of the periodic table. Now, let's establish something. When it comes to the organization of the periodic table, Dmitry Mendeleev first organized the periodic table in the order of increasing atomic weight, okay? So when we look at the periodic table, what he was looking, it was this, okay? That's the atomic weight. So when he first looked at the elements and whatever wasn't handy during the time that he started organizing it, he did it based on atomic weight. Now, the current organization for the periodic table is not on atomic weight. The periodic table is organized now based on increasing atomic number. And if we look at the periodic table, the atomic number is this. So now it's ordered by atomic number. When he started organizing it, it was on atomic weight, okay? Now that we know about the periodic table, we know the elements, let's talk about this organization for the table that we currently have, aside from what Dmitry Mendeleev created. When we look closely at the periodic table, there are two things that we must know. The periodic table is arranged according to the similarities that these elements are going to have in terms of the properties. So there are two organizations when it comes to the periodic table. We are going to have periods, and let me use my highlighter tool. The periods in the periodic table are going to be the rows that are given here by these arrows. Okay, so each time we see a row, so for example, this row, This row is a period. This row is a period. This row is a period. This row, okay? Those are my periods. To date, we know that the periodic table has 7 periods. This is period 1, period 2, period 3, period 4, 5, 6, and 7. That's what we know to dates. The other organization that the periodic table has is in terms of groups. And the groups in the periodic table are going to be the columns, okay? You can see here that when it comes to the groups that I have labeled here, this is just showing arrows to only some of the columns. But understand that these are also included in this classification. These also constitute as columns, okay? So these are all the groups that we see, okay? Now, the groups are going to have a specific designation, okay? And these group numbers, okay, are going to have a number and a letter. I'm about to show you guys in a moment how a periodic table looks like after we finish our discussion, but understand that the group numbers, meaning the columns, are going to have a number and a letter. If the number and the letter are followed, so if the number is followed by the letter A, that is known as a representative element, okay? So when I look at this, this is 1A, 2A, 3A, 4A, 5A. This one is missing 7A, but just understand that there's an extra column here. So understand that those are the groups. It's from 1A all the way to 8A. In this illustration, we are missing at least one column, okay? But we will see it in the periodic table. Now, we're going to have our transition elements. How do you know that you have a transition element? Because your group number is going to be a number and the letter B, okay? There is an alternative system out there that just names all the columns from 1 through 18. Now, when it comes to preference, you guys, I like the letters and numbers rather than the 1 through 18. That's the one that I train with throughout my years of learning chemistry. So the periodic table that I gave you guys actually has both, but understand that the number and letter system is usually what I refer when I'm teaching. So you can see that this is a periodic table that I'm providing to you guys. This periodic table has all of the information that I just mentioned. You can see the periods here in 1 through 7. Let me use my highlighter tool. And it also has the groups from the periodic table. So understand that that 1 to 18 designation I rarely use. I do numbers and letters when it comes to the group number. Now, a couple of more things when it comes to the groups. Some of the groups actually have a common name. Group 1A is known as the alkali metals. Group 2A is known as the alkaline earth metal. Sometimes they also call them the alkali earth metals, but understand that 2A is always the earth metals. Now, when it comes to 3A, 4A, 5A, 6A, because of the organization of the different elements that we have there, We don't have a common name for those columns. 7A is called the halogens. 8A is known as the noble gases. So in the middle of this periodic table, you guys see the transition elements. The transition elements are actually group B of the periodic table. So everybody in group B, their common name is transition elements. Any questions in terms of the periodic table, periods, or groups, or the names for groups? Rachel, question.
Oh, thank you so much. I was just wondering about the rare earth elements at the bottom of the periodic table, what period or group that they were. It didn't look like they had a row or column assigned.
No problem. So there are these two rows here. That's an excellent question. That we call them lanthanides and actinides. You see those pockets right there that says 57 through 71. That's where they fit.
Yep.
The reason why they were excised from the periodic table and put on a row is that technically when they were organizing the periodic table, they couldn't put it in a vertical column. And since they have a similar property, they just put them together in a row. So technically when it comes to the lanthanides and actinides, they don't have a group number designation. We find them in terms of the period. But in terms of group number, they're not very defined for the lanthanides and actinides.
Okay,
Because
gotcha. Thank you. But they still have a period.
They still have a period.
I
It's just that
gotcha.
the group number is kind of questionable because we don't have examples of compounds with them and they're radioactive. So it's kind of like, it was one of those group proof of concepts. Just think about it, like as a scientist, you are just trying to define, like I can actually make an element. You go to the laboratory, you do the experiments and voila, yes, you can make an element. But these elements are so unstable. That's why you see in the periodic table that I showed you guys in the beginning with the images, that once we get to that, area, you see radioactive, 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 radioactive. They're so unstable that we don't have compounds made with them. They're very short-lived. So it's just one of those things that happen.
Gotcha. Thank you.
No problem. Now, one of the things that you guys need to know how to do, and in your chapter quiz, which I already posted, you guys, the chapter quiz has been posted. Also, I posted the lab safety quiz that you guys need to complete. Also, I put the pre-lab for the online lab that you guys need to complete next week. So make sure that you check those out. I will send you a friendly reminder, most likely on Sunday, saying, hey, you guys, make sure that you complete this, but make sure that you check on Canvas. You already have assignments due. So one of the things is, now that I illustrated to you guys how the periodic table is organized, we are going to need to do two types of problems. The first type of problem is going to be identifying either the group number or the period number for the descriptions that we have. The other type of problem that I want you guys to be familiar with is if I give you a description, that you're able to give me the name and the symbol for the element. The second type of question that we have here, it is something that has been incorporated into your chapter 1 homework, okay? So let's get started with the first one. So we need to identify either the group or the period, okay, that is described here. So I'm going to go back and forth between the periodic table and the statement. Or let me see if I can do this. Let me just copy this. Maybe I can just paste it. Let me just try to do something. Sometimes I make modifications to my slide as we are talking. Give me a moment. So if I take a picture of this, let me put it here. And I'm going to paste the periodic table. Hopefully this will work. Let me just crop it really quick for you guys. Right, what are you doing, thingy? Give me one moment, because on my side. Oh, there you go. Now it's going. So I'm just covering the notes, but I did a copy. So you guys are going to have all of this available to you in the lecture notes once I post them. So I know that it's kind of small, but put a 1 in the chat if you can at least see the periodic table. I just want to make sure that at least you guys have it. Great. So let's work with this. So number 1, it says contains elements indium, tin, and antimony. I know that students, when it comes to chemistry 112, have different backgrounds, but to guide you guys through this, indium, because we're learning, is IN, tin is SN, antimony is SB, okay? So if you guys look at the periodic table, we can see, let me use just a different color pencil, that they live right here. So we're talking about a row, okay? So what is the row that includes all of them? What would be the answer? Great, I like to see that. So the period that describes all of them together, excellent job, is period 5, okay? Let's go look at number 2. It begins with fluorine, okay? The 1-letter symbol for fluorine is a capital F. Fluorine is one of those things that sometimes the students confuse. You guys, fluorine, the symbol is not FL, that's Florida. So if I say, what is the group or period that begins with fluorine? What would it be? Great, we are describing group 7A. Let me correct something that I saw on the chat. We could not use period 2 as a descriptor because what is the first element that we see in period 2? Is it fluorine? When we read the periodic table, left to right, thank you guys, exactly, lithium. If the statement says begins with lithium, then the answer will be period 2. But because it says begins with fluorine, then we're referring to a group. Put a 1 in the chat if now you're getting the hang of it. You guys have more on the worksheet that you can work with, but I just want to make sure that you guys are getting the hang of it. Remember, these descriptions refer to either a group number that fits that description or a period number that fits that description. It's not to put the periods that are included and all that kind of stuff, okay? Awesome. Number 3 contains the noble gases. Where are the noble gases? Are they all in a single period or are they all in a single group? Awesome. I see people participating in the chat. Excellent. This is group 8A. Next one. This period or group is going to contain magnesium, calcium, and strontium. Magnesium is Mg, calcium is Ca, strontium is Sr. So what are we talking about? Great job, Katie and Daisy. You guys are getting the hang of it. Great job, Marisol. Yep, this is group 2A. Lastly, it contains cobalt, and cobalt is capital C, small o, nickel, capital N, small I, copper, capital C, small u. I like it. Great job. I like to see those answers in the chat. Indeed, we are talking about period 4. Okay. Questions. If we have these type of questions in an exam or a quiz where I give you a statement, are we able to determine the group number or the period and do the designation? Okay, since there are no questions, let's move on to the other type of question that we have when it comes to this, which is, let me see, paste it here. I have to make the periodic table smaller, but we can do this. I know it's kind of small, but put a 2 in the chat. Can you guys see it? At least get an appreciation for the periodic table there. I just want to make sure that we at least have it. Great. As you can see in the second type of problem that I want you guys to be familiar with, this is going to be, if I give you a group and a period, that you'll be able to tell me the name and symbol for the element that is in the description. And a question like this is actually in the chapter 1 Canvas quiz, okay? Which is basically, that's your homework. When every time I say homework, remember that's your chapter quiz. So let's get started. And I like these because it's kind of like a game. It's like a scavenger hunt in the periodic table. So I will do the first one with you guys. As you can see, number 1 says group 5A. So when you're doing that, remember, you need to be familiar with the organization of the periodic table. So 5A, let me use my highlighter tool, is here. So group 5A, period 3. Oh, period 3 is right here. So I'm going to be, where does 5A and period 3 meet? Oh, they meet at this element. So this is the element that lives in 5A and period 3, okay? So I know the symbol because it's there, which is P. What is that element? For those of you that maybe are familiar already with the periodic table. Great, phosphorus. Marta, you're using your flor again, right? Is that you? Okay, I just want to make sure that I don't say flor, but then I know that that's Marta. Okay, awesome. Great job, Katie, also. I want to say something about spelling. When it comes to spelling, I can only spell based on what I showed you guys in the slides. I know that out there, phosphorus, sometimes I spell with O-U-S, that is the British spelling. I cannot be grading every single spelling that is out there for the elements. I can only grade on the table that I gave you guys, okay? Let's do one more because it's already 7:20. A halogen in period 5. So if it's a halogen, what group number am I talking about? Let's put it in the chat. Awesome, 7A. So 7A in group 5. Ooh, I saw people already put it in the chat. Great job, Dominique. That's the answer. Great job, Katie. That is great job, Kristen. And Jade, oh, you guys got this. You guys got this. Indeed, this is iodine. And the symbol is the letter I. Make sure that you guys finish the rest of these. The answer key for the whole worksheet will be provided to you guys after we finish chapter 1. But this is all for today. Guadalupe, you have a question?
No, sorry.
Oh, no problem.